Hey students, this is lesson 633, arithmetic and geometric sequences. A sequence is an ordered list of numbers. Each number in the list is called a term. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. This difference is called the common difference. To find the next number in an arithmetic sequence, add the common difference to the last term. That sounds a little complicated, but let me give you an example for that. And I'm going to change this formula here. We're not going to use this formula, so you can just cross that right out. And I'll show you what formula we're going to use in a second. But here's an example of an arithmetic sequence. And I'll just make a real simple one. Here we go. 10, 12, 14, 16, and then this keeps going. An arithmetic sequence, notice that if I subtract any number by the previous number, I always get 2. That's what has to happen in order for it to be an arithmetic sequence. And on your formula sheet for 8th grade math, you'll notice for an arithmetic sequence, it gives you this formula written as a function rule. And so we're going to use that, and you might notice that it's the same as slope-intercept form, which it is. But so for the series that I just showed you, this one, 10 is the first term, 12 is the second term, 14 is the third term, and so on. You could actually put the term number in a table like this, and then the value of the term here. Think of that as your x and your y. First term, second term, third term, fourth term, fifth term, and you would have these numbers. So to use this formula, all we need to do is figure out what the slope is, and the slope is just the difference in the values. And in a series, it's just the difference between the numbers. That's the slope. So m equals the common difference. And then b is, remember, it's the y-intercept in a regular thing. So it's the value when x is 0. So we're talking about term 0. So we actually have to put one more term in this list to get the 0th term. But so b is the 0th term. So before the first term. So we would have to subtract 2 to get that, and so our 0th term is actually 8 here. So the equation for the series that I just created here is f of x is equal to 2x, the common difference, plus the 0th term, which is 8. And so if I wanted to find, like, say, the, I don't know, 20th term, I would just represent that as f of 20, and I would do 2 times 20 plus 8, which is 48. So that's the idea there. So just going to cross out what all this says and just think of it that way. So problem 1 here, extending sequences. Describe the pattern in each sequence. What are the next 2 terms? Write a function rule to represent the sequence. Okay, so in the first one, you will notice that it's going up by 2, so the common difference is 2. And common difference is the same as the slope, so we can say m equals 2. And then the 0th term is, remember that 4 is the first term, 6 is the second term, 8 is the third term, so the 0th term is 2, and that's the y-intercept, so b equals 2. So our function rule is f of x equals 2x plus 2. And the next 2 terms are 12 and 14. Now in this one, we're actually multiplying by 3. And that's a different kind of a situation. That's called a geometric sequence. I'm going to talk more about that in a second. But in that case, let's just get the next 2 terms by multiplying by 3. 81 times 3 is 243, and so on. And we'll get back to writing the rule for that in a second. Actually, I could go over that right now. On your formula sheet, you also have a rule for a geometric sequence. And here it is, f of x equals a times b to the x. Now a, again, is just like in the arithmetic sequence, that'll be your 0th term. And b is your, in this case, it's your common ratio. So what you're multiplying by. So in this sequence, 1, 3, 9, 27, 81. To find this common ratio, you take any number divided by the previous number. So like if I did 81 divided by 7, I get 3. So it's really what you're multiplying by, or your factor. So my equation here is going to be f of x is equal to, I need my 0th term, so I need to go back 1, and the way I do that here, since I'm multiplying by 3, I would take this number, this first term, and divide it by 3. 1 divided by 3, which is 1/3. And then I multiply that by the common ratio, which is 3, and then raise it to the x power. So let's go back 1 here. My function rule for that is f of x equals 1/3 times 3 to the x power. And you might recognize that as an exponential equation. All right, let's do a couple more problems here. Go ahead and do problem 1 and see if you understand it and see if you can write the function rule. And I'll check back with you. Okay, to identify an arithmetic sequence, we just need to make sure that the common difference. So we just have to subtract the numbers and see if we always get the same amount. So if we do 11 minus 7, we get 4. 16 minus 11 is 5. 22 minus 16 is 6. There isn't a common difference. All the numbers are different, so this is not arithmetic sequence. And we can't write a function rule for that because we don't know how to do that one. The second one, 9 minus 3 is 6. 15 minus 9 is 6. And 21 minus 15 is 6. This is an arithmetic sequence, and we can write a function rule. It's f of x equals m. Our m is 6 here because the common difference is 6. And our b is, remember that's the 0th term, so we need to go back 1 more term. So if I go back 1 term here, I'm going to do 3 minus 6, which equals -3. So b equals the first term minus the common difference, which is -3. So my function rule is 6 times x plus -3. All right. And in this problem, we can also represent a problem as an arithmetic sequence. Justine's grandfather puts $100 in savings account for on her first birthday. He puts $125, $150, $175 into the account on her next 3 birthdays. So her first birthday. So let's put the birthday here. We'll call that X. So first birthday, second birthday, third, fourth, etc. And then Y is how much money she has. So 100, 125, 150 is put in, and so on. We can see a common difference here, 25. And our 0th term would be, so our M is 25, and our B is our 0th term, which would be 100 minus the common difference, which is 75. So our rule for how much he gives her is f of x equals 25x plus 75. All right, we're going to look at one other type of sequence here, which is called a geometric sequence. Geometric sequence is a sequence where the ratio of consecutive terms is constant. So we have a constant ratio. This ratio is called a common ratio. Okay, so if you divide each of the entries by the same number and you always come up with the same thing, then it's considered a geometric sequence. So notice here, if we did 6 divided by 2, we would get 3. If we did 18 divided by 6, we would get 3. And if we do 54 divided by 18, we also get 3. So there's a common ratio here, and that's 3 over 1, or just 3. And to get these numbers, we can just keep multiplying by 3. So to get the first number, we're multiplying by 3 0 times. To get the second number, we're multiplying by 3 1 time, 2 times, and 3 times, and so on. So our formula for this is we take our, we're going to change this a little. Remember, our geometric sequence formula is this: f of x equals a times b to the x. A is the 0th term. So 1 before the first term. And b is the common ratio. So our 0th term here is going to be, take the first term, which is 2, and we're going to divide that by 3. We can just write that as a fraction, 2/3. So f of x equals 2/3 times, and our common ratio is 3. And then we just put that in the x power. All right? You can scratch these and just look at that other rule that we gave. Okay? So here's some examples of some sequences, and we'll talk more about this in class. If you want to practice a couple, go ahead.